Hello everyone. We are going to analyze football match statistics data. The dataset contains 25 years of football match statistics from 18 different leagues. We will collect the dataset from this particular Kaggle URL, and here you can see we have data card. So here you have different leagues, like from Germany you have different leagues. So these are the columns. Okay. So this is match information: country, league, home team, away team, home score, away score, season, year. So obviously we are going to see these columns. So first of all, you can download the CSV file from here. You can download the CSV file, and we are going to use Google Colab. You can do this in Kaggle itself, but we'll do it in Google Colab. So here, just upload your file. So the file is being uploaded. It's a 33 MB file, so I'll just pause it since it gets uploaded. And the file is being uploaded. We will import Pandas as PD to read the data, and we'll write df is equal to pd dot read underscore csv. And here, once your file is uploaded, just copy path and paste it here. Now we can close this, and let's see df dot head. If the file is read properly, you will see the columns. So here you have country, league, home team, home score, away score, season, year, date, day, date, hour, first half, and we have different columns. Okay. So the first thing is, what is the shape of data? So you can see there are 91 columns and 95,384 rows. So it's a very big data. And in order to get all these names that we just saw there, so you can see columns are divided into groups like match information, goals and timing. Then we have cards like home team yellow card, player who received yellow card, why, substitution, home team substitution, current time, home team substitution, player who got substituted or not. Then we have match statistics, additional statistics. So obviously there are a lot of columns, and what we are going to do, we will simply write df dot columns here. So after writing df dot columns, we will simply see the name of all columns, so that suppose if we have to analyze something, then we can check what type of value is there. And just to understand, you can see in the data we have country, league, home team, away team. Let's start from the last column. So we have attendance value, capacity, venue name is given, referee name is given, pass success per host is given. Okay. Here obviously we have a lot of null values. Dangerous attack host, dangerous attack home. This is interceptions by host, interceptions by home. This is cross completed by home team, tackles by home, completed passes host, completed passes home, total passes. So it has a detail of passes home. So you can create the statistics cards for every match. Yellow cards given by the host team, or yellow cards given to the host team, yellow cards to the home team, and red card host, red card home, fouls by host team, fouls by host team, goalkeeper saves by home team, throw ins, throw in home, offside, corner kicks, free kick, blocked shots, blocked shots by host team, uh, this shots of goal host. Okay, we have this, and more importantly, the data for suppose a goal is scored. So home team goals current time, its time is given in a list, and home team goals current score is given, and then home team goals is given here. Okay, and home team goals assist is also given. So in a list, because list is a ordered value, so goal scored will be player A and will be assisted by this player. Okay, and away team is scored one goal at 75 minutes. That's why the score line was 4-1 for this match. And away team goal was by top K and assisted by this player. Home team yellow card time is like this. Okay, so this is our data. Obviously it will need a lot of transformation, but we have this simple data, so we can go to transformation in Power BI if needed, but since we are using it in Python, so we are just analyzing it here. I just saved it to Excel so that I can download this data in Excel, because in Excel there was some problem when I was opening it in CSV. So now let's try to explore this data in Python. Once we have more knowledge about what data is representing, now we can begin our exploratory analysis. So let's find out how many different countries are there. So in order to do that, we can write df, and in one square bracket, we can write the column name, and we can use the value underscore counts property in order to find how many values are there. Okay. So here you can see in the data we have England, Italy, France, Germany, Turkey and Spain, and total count of matches for England is 26,107, Italy 20,000 and so on. So you have the values, and what we can simply do, we can represent these values in form of a graph. Okay, so we can write like dot plot kind is equal to bar and fig size is equal to 10 comma 5. I will just reduce its height 6 comma 3, because we just want to see the values. Yeah, so we have value count of countries. We can also use plotly for this. So in order to use plotly, we can import plotly express SPX, and for bar chart import plotly dot graph objects as geo. So we'll create geo dot figure. Here our data will be geo dot bar, and in bar you have to provide x and y axis. So x axis will be df dot country value count dot index. So whatever value count index is there, in y we will have country dot value counts dot values, and we will show the figure. So this will create, import the library and create a simple graph for us. Okay, and here the what is the benefit here, because here you don't get to see the values when you take your mouse over. These are kind of interactive graphs. So, and we have done another separate video where we have demonstrated how to create, interactive graphs in plotly. So you can see all the values here. And if you want to update the figure size, you can write figure dot update layout, and there you can provide width and height. So now we will simply hide this. So we have this simple figure, and with plotly important thing is you can download them as PNG file if needed. So here we can see the entire data. Next is in the same way we are going to see, obviously we don't have to import them again and again. We will see league wise count of matches. Okay, so to find league wise count of matches, here we will just use the league name. Remember the column that we are going to use here is league. So we'll do the same thing, league dot value counts, and in y there will be league dot value counts dot values, and in x it will be index. So basically when you write value underscore counts, okay, so obviously for beginners we will show this. So when you write this code, this is one of the most used code for exploratory analysis. So when you will use this code, you will see that here this is a series output, a 1D series output. So here your country name is your index and count is your value. Similarly, if you will write it for league, so number of leagues that are there, obviously there are so many leagues like Championship League, Serie B, Premier League, League 2, Serie A, 2 Bundesliga, FA Cup, League 1, La Liga, and so on. So there are so many leagues and their matches are also given. So here when you will do that, so index will take your league name from here and value will take you the count value because we are writing values. Okay, here also we are going to use similar layout, and here you can see the value. We will increase the height by 320 and width by 600 to see it in a better way. Okay, so this is the graph, and let's try to auto scale. So here you can see most number of matches are championship leagues matches, then Serie B, then Premier League, and so on. For exploratory analysis, what you have to do is every time you have a data set, write df.info. So you will get information of obviously all the columns and how many missing or available values do they have. So we have total of 95,384 entries. In countries, we have all available values. League also, all values are available. Home team, everything is available. In second half, obviously, we have half values because in second half, okay, in some cases, we don't have these values. So this showing, yeah, in some cases, we have the missing values. And in home team goals current time, we have these values. So this will simply give you an idea. For example, here attacks home, attack host, we have a lot of non-null values. So this gives you an idea which particular column has most number of non-missing values, and then on the basis of this you can start your data cleaning, you can start removing unwanted columns. So currently we are just going with a simple exploratory analysis. Advanced analysis and cleaning will be performed in the second part. Now as you can see, we have team names in both team and away team column. Okay, so what we can do here, we can simply combine these two columns by using pd.concat. So with the help of pd.concat, we are creating a list here. In the list, we are using first series df home team and second series df away team. Okay, and here after concatenating them, we are saving them inside team names, and we are calculating the total value counts of unique team names here. So this will give us value counts. So you can see the most number of values are for Juventus, Sampdoria, Inter, Lazio, AC Milan, and so on. Okay, and in total we can see there are 2,947 such teams. So here is a simple thing while analyzing this data and seeing other resources of this data on Kaggle also. So you can see the team name, for example, Hoffenheim. This team name has 311 records, we can say. So we have simply written if home team string contains Hoffenheim. Okay, so we are just filtering the data set where the home team contains Hoffenheim. So this will simply give us all those matches where the home team is Hoffenheim. Okay, and if we'll write value counts, so home team dot value counts, we want to see what names are there. So you will see the name is also written in some cases, maybe because of mistake, it is written as slash n2. So what we can do, we can simply run this simple command. So for example, Hoffenheim slash n2 will be replaced by Hoffenheim, and these other two names will also be replaced by their correct team names. Okay, and what we are going to do, we are going to create a dictionary of team replacement. So if while analyzing you find another team name, for example this, okay, so you can also include that. And obviously we what we can do, we can simply write it like this. Okay, so if Hertha Berlin, it does the same, so we can simply replace that. So here we have a syntax error. Let me correct it. So this is one simple example how to clean your data set. Okay, so if we want to check like if the home team string contains slash n2 somewhere in the name. Okay, we are just matching this pattern. So let's see, you can see there are a lot of teams and we have actually 237 rows here. Okay, so here you can what you can do is, obviously we are not going to do it one by one, but what if we select these home teams? Okay, like Dortmund has this mistake, Hanover. So let's select these names. Okay, so here, not this, so we will select these names in a series. All these names are now in our series. Now we will use this and we'll create a list. Okay, names list is equal to list of this particular thing. So we will have a names list. Okay, now so we have all those names. Obviously there are a lot of names, and here what we have to do is we just have to write this team replacement command for these names also. So let's try to give a prompt. Let's say what uh, it will say. So in in names lists there are team names containing slash r slash n2. So I have just given some prompt. Let's see what it says. So here it is giving us a example. Team replacements home is equal to name dot replace slash n2 with this for names in list, and you know df home team is equal to df home team dot replace. Let's run this, and now when we will run this, obviously we don't have these names anymore. Obviously you can apply the same type of cleaning on uh, away teams also. So we will just use the same thing for away team because this name may be present in the away team also. Okay, you can make this code obviously more efficient, but this is a simple way of doing it. Now we will have our fresh data set, and where we probably have the clear or clean team names, and we can save this after applying all the data cleaning from here. we can save it as Excel. Suppose we have to analyze it in Power BI, just giving you an example. So then we can clean it here and use it there, or we can do a lot of data cleaning there also. And since it is we are saving it to Excel, so you can see in some cases we also have slash r. So in the same way we can also remove slash r from their names. In the data set, the home score you can see is given like 4, 2, 3, 7, 2, huge margin. So in this case, there will be the home team and away team scores. Okay. So with the help of this code, we can find the team scores home and team scores away, the aggregate home and away scores. So in our case, the data will be df.group by. So with group by, we are grouping the data by home team, selecting the home score column and using some property and resetting the index. Okay. So it will give us sum of home score and sum of away score. So it will create these aggregate. It is saying unsupported. Let's fix this. So you can see the home score and away score are being interpreted as object or string value here. So just to fix this, we will convert home score and away score column to numeric. Uh, Earlier this was not giving us errors. I don't know why this time it got us. It was being read as numeric. If it is not being read as a numeric value, you can use the toNumeric function or method to convert your value into a numeric value. So this will give us team scores home. Okay. So every team, because we have grouped by home team and their total score. Okay. You can also use mean here. So in order to find on an average how many goals they score. So for example, here you can see df.group by home team home score dot mean. Okay. So now let's try to sort them in descending order to see. Here you can see Savona, their average home score is 6.0 Pirai, and obviously there are other values. So you can see obviously there are a lot of teams. So later when we'll use filters, then obviously you can see between those popular teams also which team has the highest away or home score. Now we want to see how the name of Barcelona or Real Madrid is saved in the dataset. So I have just written df where df home team string contains Barcelona or home team string contains Real Madrid. So looks like their name is written pretty straightforward. Although in Barcelona we'll need some cleaning. So Real Madrid or Barcelona are written like 131, 131. These are the values. This is B teams. So by combining these two, we can see between Real Madrid and Barcelona, their average home score is 2.7 and 2.4. Okay, so this is something that you can use as just as a reference. Suppose you want to compare two teams, so what you can do, you can find what is their name written here, and then on the basis of this, you can simply compare them. We were just trying to find out their average home score, which is 2.7 and 2.4 here respectively. So now earlier we created team scores home and team scores away. So what we are going to do is we are will rename the columns for consistency. So we'll just call them teams, and here their home score will be home score, away score will be away score. So in team scores home rename, team scores away rename. So we will do the renaming and then we will simply merge on team. So team scores, so that final data will be team scores pd.merge. We are going to merge these values. So team scores home and team scores away, merge these on team because their name is now given as team. Okay, and we are going to use outer and fill any missing values as 0. So now we will have the team scores data frame. Okay, here now with the help of this you can see the team name, their home score, and their away score, the aggregate value that you are seeing here. So we use sum, and as I told you, you can also use average. For average, you can use mean. Okay, as I showed you here. So you can try that also. Here we have just used sum to aggregate their scores. Now after this, we will simply add a column for total goals scored by each team, that is home plus away. So in our team scores, we are just adding a new column, and now you can see total score is this. Okay, whether it's a home score or a away score. So this is just an addition of these two columns. And now we are going to sort by total goals scored. Ascending is equal to false. And we are going to save the value in team scores. You can see Bayern Munich total home score 1228 and away score 1051, total score 2279. Then there is Manchester City, Arsenal, Juventus, Chelsea. If we write dot head, okay, so and write 10, which are the top 10 teams in terms of most home or away scores. Let's try to create a bar graph by setting the index as team name. Kind is equal to bar. So here you have Bayern Munich, Manchester City, Arsenal, Juventus. I'll use bar H, will give us a better graph. Name will be read properly. Yeah. And just in order to see them in their ascending order, here is the simple graph. So there is score and everything is given here. So this is a very simple example. Obviously, there is a lot more to do here. So the, this is only the first part where we try to demonstrate how to set up this. In the next part, we will explain more exploratory data analysis steps and more meaningful graphs that will actually give us, you know, valuable insights in gaining information from this data. So please subscribe to our channel if you want to receive more updates on this particular football match statistics dataset analysis. Thanks for watching. Have a nice day.